Mathematics class. Today we'll be learning laws of indices. However, before we get into the mathematics aspect of our class, I just want to take this opportunity to say, as teachers, we are doing our utmost. We are trying our best to reach all of our students. I know I speak for myself and I speak for many of my colleagues out here. We're living in a time very hard to deal with. We're living in a pandemic. Now, students, as teachers, we're doing our best. We're reaching out to you. We're asking you, please help us to make things better for you. Parents also, we beg of you to work with us as teachers. We know it's not easy. Not everybody having Wi-Fi and all of those stuff. We know it's not easy. The ministry is actually working on those things. So for those persons who are able to log in, whether it be on Zoom, Google Meet, so forth and so on, we beg of you, parents, help us create an atmosphere that we consider to be conducive to learning for our students. All right. Now today we are looking at what we said before, laws of indices. So there we have it. We're looking at laws of indices. Now, there are 6 laws that we need to know. 6. Some teachers might say to you that there are 7 laws. Yes, but at this level, we're talking about 6. Now, before we actually start looking at the laws of indices, we first want to look at numbers written in their index form. We want to see how we can write numbers in their index form. Now, a number written in its index form would look something like this. Now, notice here, we read this as 3 to the second power. Now, this 3, we refer to that as our base, while this 2, we refer to it as the index, the power, or the exponent. So we can use any of those 3 words when we're referring to this little number. And if you notice where this little number is situated, it is to the right and a little bit above the number. So this one is called the base, and this is now called the power. That's how we're used to it. Now, students, every single time you see a number written in this way, what I want you to understand is that this little power here, it is always telling you something. It's always telling you something. Now, what is it that this power is telling you? Now, I want you to take out your notebook, because I will be telling you some things and I want you to just jot them down. All right? So the power is actually telling you how many times you should express the base as a product. The power here is telling you how many times you should express the base as a product. To put it simple, this power is telling you write down the base 2 times and then multiply them. That's what it is saying. So 3 to the second, it's telling you write the base 2 times and then you multiply. So this would have been 3, 3, but we must multiply. Therefore, our result there would have been 9. Another example, we could look at, say, 5 to the third power. Now notice here that since the power is 3, it is actually saying to you, write down the base 3 times and multiply them. That's what it is saying to you. So here would end up with 5 times 5 times 5. All right, so that's what it is actually saying to you. Now that we understand when a number is written in its index form, what the power is actually saying, then we can actually look at some numbers in their index form. All right, so I'm just going to, all right, let me leave that for a little while, and I'm just going to come to this part here. Now, if I write a number, say the number 4, when you look at that, you're not seeing any power up there. But what you need to understand, a number written like this, then the power becomes 1. So even though you're not seeing it, with your mind's eye, you must know that the power up there is 1. All right? Now we're going to write some numbers in their index form. So if I should pick 4, we're saying that we could write 4 another way in its index form. And 4 will be 2 to the second power. All right? We can write 8. 8 would have been 2 to the third power. What about 9? This would have been 3 to the second power. What about 16? 16 could be 4 to the second power, or it could have been 2 to the fourth power. All depends, all right? What about 25? Then this now would have been 5 to the second power. So those are just a few of the numbers that we could actually write in their index form. Now, looking back at this that we have here, remember that we say that the power is always telling you how many times you should express the base as a product. Now, I'm going to just erase this part. Erase this part here. Now, if I should write, say, 3 to the third power, then this is actually saying to you the base must be written 3 times, and then you should multiply. So this now becomes 3 times 3 times 3. Now we know that the answer to that would have been 27. All right. Now what about, say, 2 to the fourth? This would have been 2 times 2 times 2 times 2. We realize that that would have been 16. Now, what if I should give you, say, 5 times, take it this side, 5 times 5 times 5 times 5. Now notice, we write it out like that. What would have been the index form of this particular number? Now notice here that the 5 is written down how many times? 4 times. It simply means that the index form of this number would have been 5 to the fourth power. All right? That would have been 5 to the fourth power. Now, right here, we can start looking at the laws. Now, if you notice here, we have 5 times 5 times 5 times 5. Here, the power of 5 here would have been 1. Here, it would have been 1, 1, 1. Now, how is it that we could get 4 from all of these numbers here? All we need to do is to add them. So we're adding these numbers. So 1 plus 1 plus 1 plus 1 will give me 4. this can only happen, student. It can only happen if the bases are the same and you're multiplying. So notice when we check here, all the bases are the same. So all the bases are the same here. What did we do? We just went ahead and we add the numbers here and we get it in that form. Now, what if I should give you, say, 3 times 3 times 3 to the second? And I ask you to work that out, all right? Writing your answer in index form. Now notice the power of this 3 would have been 1. The power of this 3 would have been 1. Now, based on what we learned here, that if the bases are the same and you're multiplying, then we can just go ahead and add the powers. All right? So here we would have now, I could put it below, just create some space there. So I would end up with 3 to the first plus 1 plus 2. When I add all of that up, I will end up getting 3 to the fourth power. All right? So basically what we have done right here is to look at the first law, which is your multiplication law. Now, what I will be doing on the board is that I will be writing these laws in symbolic form. What you can do in your notebook is to write it down in the sentence form. So I will tell you the first law, which is the multiplication law, and it says, when multiplying and the bases are the same, we add the powers and keep the same base. So when multiplying and the bases are the same, we add the powers and keep the same base. Now, you might ask the question, why is it that we need to learn these laws of indices? Now, when you have some very small numbers working with, it's easy for you to just go ahead and multiply them, right? But it becomes a bit tedious. If you don't have a calculator, and you're working with some large numbers, then laws of indices will help you to evaluate or to work those things out in a much easier way. So that's one reason why you need to learn laws of indices. Another reason is that when you reach to the aspect, say algebra, laws of indices will play a great part in the calculation as it relates to algebra there, all right? So that's the reason why we need to learn. All right, so I'm gonna clear this part. And I'm going to have the law structured in such a way. So the first one we have here, 1, and this is now multiplication. And it says multiplication law. Here it says if you have A to the B multiplied by A to the C, then this is now equal to A to the B plus C. That's what it is basically saying. So if you're multiplying and the bases are the same, all we need to do is to keep the same base, but we're going to add the powers. Let's look at some examples quickly as it relates to the multiplication law. So we could say, if we have here 2x to the third times 3x to the fourth. All right, to simplify that, you're asked to simplify that expression. Now notice here that this is 2x cubed times 3x to the fourth. Now, one thing you need to remember here is that multiplication is commutative. The order in which you set the things that you're multiplying, it really doesn't matter. It will give you the same answer. So this that we have here would have been 2 times x cubed times 3 times x to the fourth. Now, because multiplication is commutative, what we're going to do now is to just rearrange what we have here. So we'll end up with 2 times 3 times x cubed times x to the fourth. Now 2 times 3 will give me 6 times. Now here we have x to the third times x to the fourth. What do you notice about the bases? They are the same. So in this case, we are going to keep the same base, but we're going to now add the powers. So it becomes x to the 3 plus 4. So this now becomes 6x to the 7. All right, so that becomes 6x to the 7. So that's one example as it relates to the multiplication law of indices. All right, moving along. Moving along. Now, we're moving to the second law. But before I actually tell you what the second law is about, I'm just going to ask you to divide 125 by 5. So if I divide 125 by 5, what would be the answer here? Yes, you're correct. That would have been 25. All right, so notice here, the operation that we're now looking at is now division. Now, 125 divided by 5 is equal to 25. That's easy, we know that, right? Yes, we know that. However, we're going to actually write this very same statement that we have here in a different form. We're going to write these now in their index form. All right, and you will see what happens there. Now, 125 would have been 5 to the third. Divide. Now, I cannot write 5 any other way than 5. So it's going to be 5 to the 1. All right, so this now becomes 5 to the first. And this now, 25, is the same thing as 5 to the second. So this becomes 5 to the second. Now notice what is happening here now, students. We are now dividing. So we are inspecting what is happening. We are dividing here. But what do you notice? The bases are now the same. Okay, good. Let's examine the powers now. Let's examine the powers. We had 3 here. Here is 1. Now it becomes 2. Now what can I do with the 3 and the 1 here so that eventually it works out to give you 2? Yes, you're correct. All we need to do is to find the difference. So here, all we did here was to say 5 to the third minus 1. So if I take away 1 from 3, then that is going to give me 2. So here we end up with 5 to the second. Now, could we coin a definition for the division law? Yes, we can. So from this, we realize that when you're dividing, if the bases are the same, all we need to do is to subtract the powers. If the bases are the same when you're dividing, all we need to do is to subtract the powers. All right, so I'll take this off. All right. And I will now write it in the symbolic form. And I would now say x to the a divided by x to the b. This is going to give me x to the a minus b. All right, so that is in the symbolic form. Remember, as I'm giving you the meaning, you can just write that down. No, so that's 2 out of the 6. Now the third one, I'm going to go straight ahead and tell you that we're looking now at the 0, the 0 form. Sorry. So we're now looking at the 0 form. Now, have you, in your math class, anyone would say to you that any number raised to the power of 0 is equal to 1? But the question is, why is that so? All right. Now, let us prove this 0 power here. I mean, if you have heard it before, fine, we're going to prove it. If you didn't see anything like this in your math class, then you're going to learn it for the first time. All right. Now we start off by writing this down. 25 divided by 25. What's the answer to that? If I divide 25 by 25, then I'm going to get 1. All right. So 1 is the answer. So any number except for 0, any number divided by itself except for 0 is going to give you 1. So any number divided by itself except for 0, it is going to give you 1. So keep that in mind. Now, notice here, we're going to now rewrite these in their index form. So 25 is the same thing as 5 squared divided by 5 squared. Now, 5 squared is the same thing as 25. 5 squared here is the same thing as 25. So anything that I get for my answer here, it must be the same thing as 1. So if I should write it over here, that's just what I'm talking about. I'm saying 5 squared is equal to 25. Good? 5 squared here is also equal to 25. So let's see what happens now. Let's jump back to the division now. We're going to use the division law now to help us to prove the 0 power. Now, if I am dividing and the bases are the same, what should we do with the powers? I am dividing and the bases are the same. What should I do with the powers? Yes, you're correct. We should subtract the powers. Now, if I go ahead and I subtract the powers there, then 2 from 2 here is now going to give me what? 0. So I'm now left with 5 to the 0. Now, let's go back here. We're saying that 5 squared is 25. This 5 squared is also 25. 25 divided by 25, we know is 1. So this 5 to the 0 must be equal to 1. So here, we end up with 5 to the 0 is equal to 1. All right? Now, having done that, I'm going to say this to you, that when you think about the 0 power, always look at it in the sense that a number is being divided by itself. A number is being divided by itself. So if I should put, say, 6 to the 0, I can actually look at it as this is just 6 divided by 6. So 6 divided by 6 is equal to 1. Good with that? Now, for you to write down your definition, I will just tell you what it is, and then you will just quickly write it down, because this is very, very simple. Now, any number except for 0, any number except for 0 raised to the power of 0 is equal to 1. Any number except for 0 raised to the power of 0 is going to be equal to 1. All right? So it's very, very simple. And if you think about what I had said to you before, where we said that any number divided by itself, except for 0, is going to give you 1. So you realize that we kind of tie it into this part here. When you see the 0 power, we know that, okay, it's the number dividing by itself. So if we divide 0 by 0, we will never ever get 1. So that's an exception to the rule. All right, so any number except for 0 raised to the power of 0 is going to give you 1. So I'll write that down in a symbolic form again for you. It doesn't matter which number. So we say 5 to the 0 is equal to 1. 100 to the 0 is equal to 1. X to the 0 is also equal to 1. So those are in symbolic form. You can actually write down the sentence form for those rules. Now, we're running out of time, but I'm going to try to see if I can just squeeze in one more law for you, which would be the fourth one. And this one we refer to as the power to power. Now, quickly, let's jump into this little activity. What if I have 8 squared? Now, 8 squared would have been the same thing as 64. All right, 8 squared would have been the same thing as 64. But from what we learned before, we can write numbers in their index form. So I would love for you to tell me how I could write this number 8 in its index form. Now, this number 8 can be written as 2 to the third. What I just wrote down on the board is really 8. But what I want is 8 squared. So since this is 8, I have to now put back that power on the outside. So it's now 8 to the second power. Now, what is the base here? The base is now 2 to the third. Now remember, from earlier with the multiplication law, even before that, we say that a number written with a power, the power is just telling you how many times you should express the base as a product, how many times you should express the base as a product. So this is telling us that we should write down 2 to the third 2 times and multiply them. So it becomes 2 to the third times 2 to the third. This is now equal to 2 to the 6th. However, we didn't have to write it like that. We didn't have to write it like that. Right here, we could have gotten 6 from these two numbers here. How do we get 6 from these two numbers? Yes, you're correct. All we need to do is to multiply them. All we need to do is to multiply these. Therefore, we will be picking up from here in the next class, but all I'm asking you to do is just to go through and practice. As I normally say to my students, practice the simple things, because the complex ones are made up of many of the simple ones. So when you can solve the simple ones, then you'll be able to solve the complex one. Have yourself a wonderful rest of the day. Thank you.